Hey everyone, it's Andrew Couch here, and it is Tuesday. However, for Tidy Tuesday, we're not actually going to be analyzing the Tidy Tuesday dataset. Instead, we're actually going to try to recreate a chart from The Economist. And this chart's called If Everyone Had Voted, Hillary Clinton Would Probably Be President. It's labeled the silent majority. And what's really cool about The Economist is they have a lot of really kooky charts that they really try to push the bounds of data visualization. And what's actually really cool is they have an actual GitHub repo that we can look at. So right here we can see the repo on GitHub, and they actually have a little folder with their graphic detail data. And the reason why I chose a silent near majority is because they actually have the data set. So we go all the way down here. We can see if everyone had voted, Hillary Clinton would probably be president. So that's pretty cool that we have the actual data that was used to create this visualization. And I think it'd be cool to recreate this really it looks very complex, but we can actually do this in ggplot pretty easily. So I'm going to go and open up R, and I'm going to put this in a markdown file. And I'll call this, let's call it recreating the Economist viz. Okay. So I'm going to make this full. Always load in the Tidyverse. And this time we're going to be actually going in, and I'm going to show you kind of how you pull in CSVs from repos. And you can do this with, I think, most publicly available repos. So another good one is the John Hopkins COVID data sets that you can look at. But for us, we can actually look down and read. The main image was generated using the included data file, state level estimate with probs. So we're going to go to state level estimate with probs or probabilities. We're going to view the raw data set. And then we're just going to copy this link. And let's see here. We're going to go here. We're going to say df reader, and then we'll say read CSV. And we'll paste this in. I believe this is in state level estimates with prob. Yep. Okay. And we'll just do a basic glimpse first. All right. So we have a state abbreviation, rep 2016 actual, 2016 predicted, total EVs, rep mandatory, dem mandatory winner, dem EV. Okay, so this stuff, I'm not really sure what it's supposed to mean. However, we can go in and actually look at the data dictionary that they've given us. So state abbreviation, that's pretty self-explanatory. Rep 2016 actual vote share, actual vote. Okay, so actual means actual vote share. That makes sense. Pred means predicted vote share. So that's pretty cool. Total EVs is total electoral votes. Dem mandatory is, I guess, a model prediction if everyone voted. Winner, which means who won. Dem EV, how many electoral votes won. Okay, and then just basic predictions. Dem. So this is also them predicting, I guess, how many electoral votes, and then how many electoral votes given that everyone was required to vote. And then also we have probabilities of winning the state. And when we actually look at this visualization, we don't need this entire data set. So if we look at it, it's saying, okay, so we need the states. Every state is shown. We see these kind of ranges, which I'm not really sure about, right? So let's look at it, and we can see right here, there's a little key right here. So since the entire thesis is basically saying that when there's a higher turnout, Democrats will generally win, we can see that with everyone voting, it's always going to go to the left. It's always going to go to the left. So that means like when we increase turnout, more Democrats will more likely be able to win that state. So the right side is the original 2016 turnout, and then the left side is if everyone turned out. So looking at this, you can see, oh wow, like Texas, it's a red, so it's 70% likely to go for Trump. However, if everyone turned out, then it'd actually be about like 58% chance likely to go to Hillary Clinton. And then you can see how the blue is like right now they're like if they're the right side is for the colors is saying like okay, so they're gonna be Republican, like it's favoring Republicans. The left side is whether it's favored to be that party. So just to summarize, right side is current just number of electoral votes. So right now, if it's red, it means currently it would be favored to be a Republican. If it's blue, like this one, it'd be favored to be a Democrat. And then if we force everyone to vote, then it goes to the left side, and we can see what it would change. So we can see how there's a change from Arizona, Pennsylvania, Wisconsin. However, for say Ohio, if we force everyone to vote, it would still say Republican. For Iowa, it would still say Republican. And then it says mandatory voting would help Democrats more in Mississippi more than any other state, because you can see that huge range. So from 80% to almost to almost like 53%. Okay. So that's pretty cool. What we're gonna need then is we're gonna need to know the state name, and we're also gonna need to know the probability of winning that state, and then probability of winning that state if everyone votes. So we already know we need 3 columns. Okay. Lastly, if we notice, some of these boxes are different, I guess, widths or heights, depending how you want to view it. See how Texas is much wider or larger than, say, Mississippi. And what they're also using is number of electoral votes for I guess 2016. So Texas is worth a lot of electoral votes, and it's saying that if everyone voted in Texas, like Texas is the main dog that we would probably focus on if we were going to try to do some type of huge focused turnout campaign. Whereas if we really want, if we did a huge thing where if a Democratic consultant said, okay, if I can decide between any state to basically force or require some Australian style mandatory voting, it would be Texas. It wouldn't be Mississippi, and it wouldn't be, say, California. It'd be Texas, because it's worth a ton of votes that crosses the line. Lastly, one thing that I really like about this visualization is, one, there's a lot of, it is a really it kind of seems almost like a chaotic chart, but the Economist knows that people are going to spend some time looking at this, and it does actually look pretty organized, right? So we have this main chart, we have a nice key that explains the chart. We also have these nice little paragraphs kind of help explain the thing. There's a little disclaimer saying Maine and Nebraska treat as if they gave all their electoral votes to statewide winner, even though they don't. They do like proportional voting. And then they finally have this, where it's just a basic summary of this entire chart. So it's kind of a chart within a chart, where it's saying, okay, actual result, simulation with 2016 turnout, and then if everyone voted, you can see the basic change, and that's the whole thesis. Okay, so that's a lot of talking for something that we only needed 4 things, right? And what's really cool about this is like the Economist is basically the best news publication for data visualization. So they always do a daily chart or a graphic detail article, which just does an article about data visualization. So they're really good at it, and they've been doing this style for a long time. Okay, so let's go back here. Let's see here. So what we know is we need to select state abbreviation or the name, right? Notice how there's 51 rows. We need to know their electoral votes, so total EVS 2016, and we need to know the Dem probability. We need to know the probabilities. So we have probability mandatory, and we have Dem probability 2016. I'm gonna switch them around so I don't get confused. And what we're gonna do actually is this entire thing is kind of a long thing, so we'll just call this one probability. We'll call it prob. We'll say prob equals 2016 probability that the Democratic candidate will win that state, and then we'll say prob mand equals Dem probability for mandatory. Okay. So I think we should do some basic data cleanup. So I think for probability and prob man, we should change it to like actual percentages, because if you look at our chart right here, it's in a percentage format, or you could just say it's not in decimal format. So let's just remove it from decimal. So we'll say mutate at, and then we'll say vars contains, and we'll say prob. So what does it say? It's saying like we're gonna only mutate at columns that contain the word prob. Okay, and we'll just do a little function. We'll say times 100. I think that's how dot x times 100. This is basically just kind of like I think a custom little helper function. I think the Python equivalent would be like a lambda or something like that. So boom, we did that. So it's saying like, okay, any column that contains the word prob, we're gonna take that column, which is basically a synonym for dot x, and we'll multiply it by 100. Okay, cool. So if we did that, we can see how like DC has a 100% probability of being won by a Democrat. Let's just do a validation or a sanity check on it. Oops. So DC all the way down there, 100%. That makes sense. We also can look at Utah, Wyoming, West Virginia. So let's look at that. Okay, so Arkansas. Oops. Arkansas has like a 0%. It has 0%. So this all makes sense. Nothing crazy is going on. Okay, so now let's just do a basic ggplot. Okay, and I know you're thinking like, okay, wow, how do you even start with this chart? This chart's crazy. Like you have to be insane. But what we know is we can just divide it in a basic term, right? So we know that all the states are on the y-axis. So we'll just put that in first. So AES aesthetic y equals a state abbreviation. And we'll just say, let's do the x-axis first. And we know the x-axis is probability, but we don't know what is what. So I think the best thing is let's just start basic and say, oh, let's just plot out the probabilities where y equals state abbreviation. And let's just do a geom line, right? Cool. So that's not going to obviously do anything because we're having it grouped as state. However, we can see that it is like almost like a box plot. It's not a box. It's like almost a column chart. But what we do see is we have the probability of with 2016 turnout, and we have the probability with everyone voting. So what that means is we could actually kind of do something like a box chart, but we can just simulate these as lines, right? Because we don't, let's just ignore the widths of it or the number of electoral votes, and we'll just call this as a line, which means you could just do a geom segment. So with geom segment, you specify the x, y, x end, and y ends. So we already have our x and y, so we'll say x end equals prob man, and y end is the same thing, which is state abbreviation. So let's just do that. And let's see what that looks like. Okay, what do we notice here is that it looks terrible because it's not in a formatted way. It's not formatted in a, what they're doing is basically by doing it by probability, right? Because it's saying like the ones with the highest probability of being a Democratic state or being won by a Democrat is to the bottom, and the one who has the highest probability of not being a Democrat or being a Republican is to the top. So what that means is we got to do some reordering. So let's mutate, and then we'll say state abbreviation equals reorder, and we'll say state abbreviation. And I'm not sure I'm not sure which probability it is yet, but what we can do is let's just assume. Let's see here. Let's see what's going on. Let's just assume it's with 2016 turnout. Why I'm saying that is, it seems like trying to think. Actually, let's assume it's with everyone voting, because as you can see, the right side, there's some overlap between Georgia, Florida, and Michigan. However, if we look on the left side, it's almost as if it's a staircase. There's nothing. It's not like there's no little divots, right? So it follows this little staircase thing. So we have that with mandatory voting. Okay, so let's do that. Reorder by prob and. Okay, so now you see here, it's looking good. It's actually looking like it makes sense right now, and it's starting to kind of resemble almost a skeleton of what we're trying to make, right? Except we have one problem. Okay, so we have DC at the top, whereas the Economist chart has Republican favored states on the top. We can do this pretty easily by you just using a scale X scale X reverse. What this does is just reverses it. Oops, what is it doing? Scale X reverse. Oops. So scale X reverses it. So now we have oh, oops. Let me so we have Utah at the bottom. That's not what we want. And we have DC on the top. How about we do minus, and then let's see what's going on. There we go. So as you can see, there's some kind of like messing around where like basically it's taking like the inverse of an inverse, and that somehow just kind of flips it in a correct way. Okay, so a lot with plotting is just kind of just guessing and checking, messing with minuses, descending orders, and other reversing. But we do have a skeletal framework of it. This thing is looking very close to what the Economist chart is. Okay. Right, so 0 to 100. Okay, 100% likelihood, boom. So we actually, yeah, that makes sense. 100% likelihood to be a Democrat, 0% chance of being a Democrat. Okay. So now that we have GM's segment, let's just put in the size now. What's cool about GM segment is you can actually specify the width of each segment, because this is technically it looks like a line, but it's really just kind of like a box. So if we do size equals 20, it's gonna look very weird, right? But they're boxes. Notice how they're boxes instead of lines. It's because they're so small that we actually didn't know that they looked like lines. Okay, so we can change these sizes, but we kind of don't want to do that. We want to do it almost like programmatically. So we'll just say, size equals total EVS 2016. Okay, so notice how somewhat they're different sizes, right? Where Texas would be is a lot larger than, say, Idaho. However, I don't really like the look of this because I want them to be a little bit wider. So maybe I'm gonna emphasize it by just saying log 10 of state. Oh, not log 10 of state. I'll do kind of a log 10 of that. Okay. So there we have a little bit. I'm not too happy about this, but it looks fine for what it is right now. We basically want to it's not so emphasized, so maybe I can do like a 10 times log. Okay, that's not working. 10 times log. How about 10 times boom? I don't know. It's not really a big deal. I think you can definitely play with this a little bit more. I'm gonna remove the legend. The Economist never really uses like crazy legends. They use like custom made legends, and I'm actually gonna ignore this. We're gonna focus mostly on this stuff. Okay, so now we have this chart with the sizings and stuff like that. It looks fine. It has that little staircase little approach with it. We're gonna just add that nice little vertical line. So we're gonna say geom was it v line where x intercept equals, and it's 50. Boom. Okay, so we have that. Also we kind of need to have the colors. So I actually have the the pattern colors that they actually like kind of upload for you. So just looking at these colors, we can kind of look at it and say, okay, sure. I think that's like a turquoise. Let me see here. Okay, maybe. Okay, so we'll use turquoise. I think that's fine. One other thing, little trick you do is you can use the snip tool. We can kind of take a sample of it, get the color, and then we have our hex color. So let's just do that. We're gonna do that. It probably won't be perfect with a ggplot, so we're gonna do that. Okay, so with these segments, we need the color to equal, and you always use a like a little number sign. Cool. So now we have these things. Additionally, notice how it's a white background. So to get a white background, I'm just gonna do a plus theme minimal. Okay. We removed most of it. We gotta remove also the I believe they're the vertical lines. So scale Y, I think discrete, and we'll say what is it? Break line breaks equals null. Cool. So now we have no line breaks on it. We'll also do legend.position equals none. Why is this thing still on here? Okay, I'm just gonna do that. Uh-oh. Okay. So we have this. Notice how the vertical line is behind these things. It's just because like ggplot is essentially just stacking each little command on top of each other. So if you have gm vline on as the first command, then everything else will be stacked on top of it. Okay, cool. I'm not sure. Let me we'll just remove all the x labs and y labs first. Actually, we want to keep we don't want the any of the labs yet. Okay, so we removed all this. Okay, and then I'm gonna try to remove that log 10 thing. Theme legend dot position equals none. Okay, sweet. We removed that, and then we'll say labs title equals. I'm just gonna add like kind of the generic thing. So we'll say silent majority. The silent majority. So the silent majority subtitle equals if okay, if everyone, we'll write if everyone had voted Hillary, let's see, I think that's how you do it. Clinton would probably be -n president. Okay, I don't know how this -n. I think it's gonna stick with one line, so I'll call that. Actually, I'm gonna look it up first. Line break in subtitle ggplot. Okay, I don't want to do that. Okay, that looks like a lot of work for something that doesn't really matter. Okay, cool. So silent near majority. Cool. Okay, I'm gonna make what is it? Let's see. I should probably do some things. So element. I'm just gonna change the size. So element text size equals, was it 16 maybe? Silent near majority. Okay, and we'll say the color equals, and we're just gonna use the Economist red that they're giving us. So it's E whatever that is. Okay. Okay. Cool. Silent near majority. And then we'll say plot dot subtitle element text size equals, and this is the big one. So we'll say it's like what, 24. Call that. And I'm not sure if everyone had voted. Trying to think. I think maybe we could leave it, but actually I want this thing to be a little bit bigger. So silent near majority. Okay. Also, I'm gonna use this package called the library extra font. So that way we can do some little font work. And what this does is we can basically add in our fonts that we want to add. So, for example, if you notice, this subtitle has like little feet on it, which I believe is called a serif font. So we're gonna kind of say that we're gonna say I think it's family equals and serif. No, I don't really have a lot of fonts because I don't really mess with fonts, but I do have Times New Roman. So let's see if that works. It works perfectly. Great. So now that we have our feet, our little feet things on the bottom, we have a little red text on it. I think, let me look at this full screen. If Ron and Hillary Clinton would probably be present. Okay. We're gonna arrange this with we're gonna center it. That's just HS equals 0.5, and then we'll center the other one too. So HS equals 0.5. Boom. Perfect. So you can see here we are right on our way to doing a pretty cool chart. Okay. Now we're gonna have to add in. Let's just mess with the labels a little bit more. So we'll just say was it breaks, or I think it's breaks. Breaks equals C, and we'll just call it 0, 10, 20, 30, 40, 50, 80, 90, 100. There's definitely a faster way to do this. I'll probably repeat the 100, but we want to say that we want to count by increments of 10. And then finally we'll do labels, and we'll say 100, 90, 80, 70, 60. And it goes right back up. Okay. Cool. What it's saying is, okay, so what it does is okay, once it's 50%, that means it's even. So there's equal chance of 0%. 50%, 50. And then when it increases, it goes to 60% in favor for Republicans. Great. So I'm just gonna kind of separate this into 3 main things. We have our data wrangling, so I'm gonna call it data wrangling. Our actual plotting, so plotting, and then we have a formatting. Cool. Right. So we have that. All right. Finally, oops. I'm gonna make sure this thing is. All right. Finally, we want to start adding these right and left little colors. That's what makes it actually look really nice. So again, since we already have GM segment, let's just use it again, because I think this will actually add on to what we want. So GM segment, except this time, we kind of just want to make, what I'm thinking about is we're just going to make the same dimensions of this segment, but we're just going to cut it. So it's just a little sliver. Okay. So first, let's just start with the 2016 turnout. So instead of doing this entire, or having a width of this entire range, we'll say it's a width of the start minus a little bit, right? So we'll say prob, and we'll say -1. And just to make sure it doesn't do anything crazy, I'm just gonna say red, just to see if it's working. Sweet, right? So now we have red. We have red little labels on it. Okay. So we're not gonna actually say it's red. We're not gonna actually just manually say it, because right here it shouldn't be red. That's not how it works. But we're gonna do it just for um, formatting purposes, so we can remember it. So then we'll call this blue. Okay, blue. So instead of having on the right side, we got to do it on the left side with everyone voting. And so since we know xn is prob man, we'll say prob man, and instead of doing -1, because then it'll go outside of the space, we'll say +1. Ooh, whoa, what am I doing? Prob man xn x equals and we'll say since what it's doing is it's actually saying, oh, well, since you didn't specify an x value, it's just going to do prob. And we know prob and prob man are separate each other. So we have to specify our x for this one. So we'll say prob man. Dope. And we have this. It doesn't make any sense and it's violating a lot of the rules that we want to put into it, but it's doing what we want it to do. Okay. And that's important. So now, what I'm thinking that we should need to do is we need to do some logic for it. So our logic for this thing is saying if 2016 turnout is greater than probability, if 2016 turnout probability is greater than 50%, then it should be red. So let's do that. So we'll say mutate and say prob greater than or equal to 50, then it should be red. And our red, we're going to be a little consistent and say our red will be this guy. Okay. Ooh. And we'll call this prob, we'll call it right color. Just so just for ease, just for readability's sake. So if else prob is greater than or equal to 50, then we'll put in that. Else we're gonna have a blue, and this time let's look at our little what is it, our color, and we'll say sure, let's do that mid. That blue looks way bluer. So yeah, we'll just oops, whoa, we're gonna zoom in. What's that? I wanna grab that blue, so I'm gonna do a snip of that. Boom. And we're gonna open up that blue and just kind of sample it. Boom. 00931B. Don't know why I said that out loud. I have it saved. Okay. So else. Oh no. What? Oh god. For some reason, it did not save that. That's really annoying. So we're gonna go back to it, do the same thing. Okay. I think if I close it, it might just like cancel it out. But I also don't know what I'm talking about. So, okay. Boom. Okay. So else it'll be that. So now we're gonna test this by specifying the right color. The color equals right color. So color equals right color. And we're gonna remove this and see if it's working. What's going on here? If else, oops. There we go. Yeah, that's what we want. I think that blue looks a little odd, but we're gonna keep it. We're gonna keep it. Okay. So now we're gonna do the same thing, and you could do it in the same. You could put all these mutate functions in the same area. I'm just gonna do it just so we can look at it a little bit easier. So left color, and this instead will be, instead of probability, since we want the left side, it's the probability of the mandatory, right? Oh, probability of probability of mandatory, and we'll say left. We'll call that left color. So we're gonna again remove that and say color equals left color, and boom, we have it. We basically have everything we wanted. So I can finally delete that stuff. Don't save. Okay. So we have a chart. It's looking really great, right? Might have to remove these minor breaks. Let me remove that. I think it was minor. Let me look up. Remove minor breaks, ggplot. Vertical lines, scale X. But what about minor breaks? Panel.made. Okay, I think it's that. So panel.grid.minor.x equals, was it element blank? Element blank. Run it. Sweet. So now we have the minor breaks removed. Solid. Okay. Finally, I will not be adding the arrows, partially because I don't think it adds as much, and also I'm not sure if they actually use ggplot for this. They might have used Illustrator, but the general idea is that like none of these states increased probability of winning for Republicans, right? So we can just ignore that. We don't need to worry about that. Okay, but what we do need to know is we need to know which state is what bar represents each state. So what we're gonna do is we're gonna add a state name. So we'll say label equals state ab, and then we're gonna add geom text as, and x equals they have it kind of everywhere. I think they might have used like a different type of geom text package that can like basically look at it and find out the best ways to put it. Instead, I think the best way for us is we're just going to put it on the left side, so you can read the left side, kind of see the differences. Additionally, you could put it on the right side. The only reason why I kind of don't want to do the right side is because then you're reading from right to left, even though you're really supposed to like kind of read it right from left. You can see how like, oh, all of it's going left, so it kind of makes sense to look at the state from that. But you can do both ways. You can do either way. It doesn't really. I don't think it really matters. I'm gonna do it on the left, but it's very easy to do it on the right. And in fact, I might just switch it around or do both and decide which one I like the best. That being said, we know we need to put it on the. I'm gonna do it first on the left side. So we need to specify our labels x and y axis points. We know the left. If we look here, we can see, oh, our left color is prob mand. So we'll say prob mand, y equals state ab. And let's just say the color equals black. Okay, boom, easy as pie, we have it. It is on it. So we will do I think it's a nudge. I'm not sure if this will work. Nudge 1. Okay, it does. So we're gonna nudge it by a little bit. Nudge 1.5. We're just gonna nudge it to the left a little bit. I'm gonna do it 7.5. Okay, maybe it might be 1.9. Oh man, I really don't like how that thing is there, but I think we might have to leave it. I'm gonna do 2 just to make it a little pretty. Okay, so we have it all to the left. We're gonna add another geom text, and this time it'll be to the right. So we know it's prob, and we'll say instead of nudge -2, we'll say +2, and I forgot the plus. Oh. No. Let's see. What's going on? X equals, prob. There we go. And then, bam, we have it on here. You know, I am going to make this decision and putting it on the right side. So see, adding the actual text labels is pretty easy. I'm going to do it on the rights just because you're going to read it kind of from right to left. So I'm going to just remove that. actually, I'm gonna comment this out. Say boom and say left labels. Boom. Now we have on the right. We have to do a little bit more manipulation, so I'm gonna do 2.2 because there's some overlap on them. It's taking a little while for some reason. Let's look at it finally. See, these little annotations, we could add like the GG annotate. I'm not really sure how to, I think they're like arrow bars or something like that. Okay, what is going on here? Blah, 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 blah. You know what, I'm gonna remove that. Stop. Okay. We could do an annotation on it. I kind of don't want to. Additionally, what we should do though is add a Hillary Clinton more likely to win, Donald Trump more likely to win. Things right here. We could. I kind of do like that Florida thing, so we might do that too. Okay, what's going on? Okay, what's up with my art console? Huh. Okay. We got it. We got it. Everything looks fantastic. So now we're gonna add some annotations. Annotations. Okay. So right here, we should probably put it, I don't know where Wyoming is. So, annotate, what is it? Annotate, and I think the geom equals, can you do text, right? X equals, we'll say, 60, Y equals WY. Label equals test. Run. No, run. Okay, I must have done something weird on it. So I'm just gonna, I don't want to delete this chunk, so I'm just gonna copy and paste it into this other chunk. Okay. What is going, stop, don't run. Oh, wait, okay, just that. What is going on here? Very interesting. Okay, well, I'm just gonna, okay. Oh, wait, I think I have to specify the thing for it. Just let's see if that works. Okay, for some reason my thing is being a little messed up, so I'm gonna run it into another console, and we'll just do that. There we go. We'll put this guy right there. Okay. We'll exit that out. And we'll enter that. Okay, HY is not found, so I have to do, let's do, I think that's how it works, right? Okay. So we gotta make this a little bit smaller. And this is why I really do not like the annotate function, to be honest, because it's easier just to do this in Illustrator. Cool. So we have test. Okay, and we'll say what's the thing called? Hillary. Hillary Clinton more likely to win. Uh-oh. just a line break in annotate ggplot. Oh, that's why. Okay. So we're gonna put this guy right there. Hillary Clinton more likely to win, and we'll say family equals serif. Hillary Clinton more likely to win, and we'll say color equals what's the blue thing we're using right now? I think it's this one. So we'll say color equals that. Cool. We're gonna export this out a little bit. Okay. Hillary Clinton more likely to win. And then we'll do another annotate text. Actually, what is text Donald Trump more likely to win. Color equals this little red guy over here. Boop. And then in this case, the y-axis will be was it 80, right? Was it 40? 40. Donald Trump more likely to win. Cool. Great. I think that's it. Maybe I'm gonna do a little bit more formatting. Annotate left align ggplot. Maybe we can do a left align for the text. That'd be kind of nice. H just equals 0 seems pretty easy, so let's just add it into it. H just equals 0. H just equals 0. Oh, get out of here. More likely to win, and then we gotta change this thing a little bit. So we'll more likely to win. Donald Trump more likely to win. I think the size could be a little bit bigger, so we'll say size equals 12. Does that make it huge? That makes it ginormous. Size equals probably maybe 6. So let's do size equals 6. Size equals 5. Okay. And size equals 4. That's the same size. Size equals 5 then. Size equals 5. Let's see here. Donald Trump. Oh, and H just equals. Maybe we'll make this kind of like, because they're like, back to back with each other. So H just equals 1, and then we'll make this 60. I'm gonna make it actually a little bit closer to each other. Wait, 60. That's is it 70? No, it's 50, 55. And this one would be 35. Or is it 45? Great. Sweet. Lastly, what we're gonna do is I am actually gonna do the line break. If everyone had voted, Hillary Clinton would be president. So after Clinton, what is it? So after Clinton, dash N would probably be, and then dash N. If everyone had voted for Clinton, everyone had voted for Hillary Clinton. Oh, it's not. And yeah, boom. I think, God, that looks like a nice chart, right? Yeah, I think that's it. I would probably leave the annotation to someone else, but yeah, here's the code. What do we say? Data. I'm gonna just do some commenting on it. Data wrangling. The plotting, the annotations, formatting. So as you can see here, these lines of code, it is a lot. It looks very long, but a lot of it, right, was just formatting. If we look at the actual ggplots, it's really just a what is it, a 5-liner for the plots, some annotations, some formatting, some really basic data wrangling, which honestly was mostly just for formats. So I'm gonna do this, and I'm gonna put this right here. Yeah. Yeah. And you can see here, it looks very, very, very close to it. I not sure. Let me make the widths a little bit. Log 10 size. So the only thing I would really change is the widths of it, but again, it's not bad to look at. Again, you can also add arrows to it. But yeah, I'm gonna full screen it, and yeah, here's our work. Didn't take too long to do, and I'll see you guys next week. So tidy on.